Hey guys, so in this video I want to write a linked list program using the C programming language. So first I'm going to start off with a title for my program, and it will be called linked list. Now I need a description of what this program does or is about. So this program inserts a value into a linked list. It searches a value or searches for a value in a linked list and prints the value or values of the linked list. Alright, so let's go ahead. I'm only going to need one library here. I'm going to need the include stdio.h library, and it should have malloc in it, I believe. So now what we need to do is we need to create the struct that's going to form our linked list, and it's going to contain our value, our data. So struct to form a linked list of integers. So struct, I'm going to call it LL for linked list, and it's going to hold some data, and then it's going to have a pointer to a struct to the next node in the linked list. So this is kind of like defining or creating a structure for one node. Okay, so now I want to define the linked list functions. So define linked list functions. We're going to want to insert a value into a linked list. So there's two different ways we can do it. One is we can insert into the back of the list. We'd have to take in the linked list, and then we have to take in the value that we want to insert. All right, another way is inserting into the back of the list. I'm going to just copy this here. I'm sorry, not in the back, in the front of the list. And we'd have to do the same thing, a little different when it comes to implementing it. We're going to want to search through the list, so we can return a value like 1 or 0 that will tell us if the value was found in the list. And again, we have to take in our list, and then we're going to search for some value. And then we're going to need to print the list. So we don't need to return anything, so it would be void, and I'm going to just call it print. And of course, again, it's going to take in the linked list, and I don't think it needs anything else. We're just going to print the linked list. Okay, I think that'll work there. All right, so now let's go ahead and create our main function. Main void system pause. You can comment this out if you're not using a Windows operating system. Okay. And let's create our linked list. Let's call it list. And let's go ahead and set our list equal to null. So it's going to be empty. And empty linked list. Okay. Let's create one more function here. Oops. It may or may not be necessary. It was really not necessary what I'm about to do, but it may make things a little bit easier. I'm going to create a function called createNode. And it's going to take in a struct node and a value for the node that we're trying to create, and it's going to create it for us. So let me go ahead and start creating these functions, or start putting some meat to the bones. Let's see, right now I'm just going to return front for now. So if we're going to create a new node, struct start, we're going to call it a temporary node. So temp for temporary. Let's see, create temporary node and link it to, well, we're just going to create a temporary node. Okay. And so how we're going to do that? So our temp is going to equal struct linkless pointer malloc size of our struct that we created or defined up top, struct LL. So that should be pretty good. And the temp data is going to equal the num. And for now, the temp next will equal null. And we don't want to return front, we're going to want to return temp. Okay, so that's just going to create our node for us. Now let's insert into the front. So we're going to insert this new node into the front of the list. And that's going to be really simple. We could take our created node function here. Okay. And we can have front, and we can have the num that we want to create. And let's create another temp here. And we're going to set it equal to this. And now that I look at it, it looks like I won't even need this. I won't need that to create a node. So I'm just going to get rid of this. So this is going to create temp's node, and then temp's next value is now going to equal the front of the linked list. Okay, and then what we can do is we can return our temp. All right, so now let me go ahead and do the back of the list. And for now, I'm just going to return front. Now for the back of the list, it's going to be a little different, but not too much more complicated. What we're going to do is we're going to have our struct temp variable. You can just copy and paste that there. and we might need a pointer to the front. So I call it begin. So that's going to be our pointer to front. Let me see here, store front of the linked list. Okay, we're going to create temporary node. All right. So now we need to check if we are inserting into a empty or null list. So if our front equals null, then we know we're inserting into a front list, and what we need to do is we just need to return our temporary node. So now if we're not inserting into an empty list, we need to find out where to insert this new node. We need to iterate through the linked list till we get to the end of the list to insert this new node. So we need a while loop. Actually, I'm going to first say, I'm going to put a comment here, iterate through the linked list until we reach the last node. So while the front next does not equal null, then our front is going to be front next. So our front is going to become the next node each time until it reaches the end where the last node is pointing to null. And so once we've gotten there, now we can insert temp into the list. So front's next equals temp. And that should do it for that. We need to search the list. And search is pretty much the same. I'm just going to copy and paste that there. Except for if we find, we need to check to see if we find the data that we're looking for. So if front's data equals the value, then the value was found in list, and we're going to return 1. So let's return the value 1. If not, then the front's going to keep going. It's going to iterate through the list until it finds it. But if it never does, then we're going to return 0. And this means that value was not found in list, return 0. Okay, and last we have our print function. So this should be very similar again to this loop here. We're just going to print everything in the loop. So printf %d space, and we want front's data. And we don't want to check to see if the next one's null. We want to see if front's null. So that's a difference there. And then we do front's data, and then front's going to equal next. Perfect. It looks good. So let's go back to our main function and let's start actually putting in some data now. So list is going to equal insert into front. We're going to insert our list and the value 4. And then I want to print the list. And let's see if it works. Okay, so in function create note incompatible implicit declaration of built-in function malloc. So let's see here. If front equals null, we return temp. Okay, so here we need a semicolon. And now let's give this a try. Oh, perfect. So print it 4, press any key to continue. I'm going to put a print statement here for aesthetics, \n, and then semicolon. Okay, so now we can see the 4 a little bit better. All right, let's keep putting in some more values. Oops. And I'm just going to copy and paste this. And we're going to input the value 8 into the front. And then I want to put the value 11 in the back. All right, let's give this a try. So we put 4 in the front, then we put 8 in the front, so we get 8, 4, and then we put 11 in the back. Now there seems to be a problem. In the back we have 11 in the back of the list, and then 4, but we should have the number 8. So let's look at the back function here. That's why. I'm returning the front of the list, but I need to return the pointer to the front of the list, which would be begin. So return the pointer to the front of the list. Okay, so let's try that now. There we go. So 4, 8, 4, 8, 4, 11. Perfect. And let's check out the search function. If search list, we're going to search it for the number 4. If it equals 1, then we can printf found the value 4 in the list, period, \n for next line, else printf did not find the value 4 in the list, \n. Okay, so let's give this a run. So it found the value 4 in the list. Let's look for the value 8, and I'm going to change the print statement. Found the value 8 in the list. Perfect. And let's try the value 3. Change this and that there. Did not find the value 3 in the list. Okay, I'm going to actually do one more print statement of this, just so you know, we can see that it works for the value 4 and not for some other value like 3. Okay, and run that. Did not find the value 3 in the list, found the value 4 in the list. Perfect. Okay, so that's it, guys. Thank you for watching. I hope this helped you guys to create your own linked list program. I will leave the program in the description below. I will leave a link to my GitHub where you guys can just copy and paste this program onto your development environment and run it. So thanks again. Please leave questions, comments, likes. Please subscribe, and I'll see you guys all in the next video.